It is my great pleasure to welcome you to the world of learning new concepts and current trends, so let's start. Hey everyone, and welcome to this explainer. I am absolutely thrilled to guide you through today's material. We're officially kicking off SWE 4304, Databases, and we are focusing specifically on Week 01, Foundations and Architecture. If you're stepping into the world of software engineering, well, you're about to learn one of the absolute most foundational superpowers of the trade, and that is database design. Now, before we ever write a single line of SQL code, and trust me, there is literally zero SQL practice this week, we've got to master the blueprint. So get comfortable, grab your notes, and let's start constructing a relational data model right from the ground up. Have you ever stopped to think about this? What hidden engine is actually powering your favorite online shop, or your daily fitness tracker, or maybe that food delivery app you use every weekend? You know, it's super easy to just focus on the sleek user interface, but beneath that shiny surface is a highly organized, totally invisible engine. Think about it. Without it, your orders would just vanish, your step counts would be completely scrambled, and honestly, chaos would just take over the entire application. That engine is the database. And understanding how to design it properly, that's exactly what separates good software engineers from great ones. So here's our roadmap for today. We're charting a course from the macro landscape of real-world data all the way down to the micro level of your specific weekly homework. We'll hit on the hidden database engine, data versus information, the 3 schema architecture, our modeling vocabulary, how to read crow's foot notation, and we'll wrap it all up with your Week 01 deliverables. All right, let's jump right into Section 1, Data, Information, and RDBMS, the raw materials versus the finished product. Okay, so let's start by getting our shared vocabulary straight, especially with two terms we honestly use interchangeably way too often, data and information. Think of it kind of like being an architect or a builder. Data, that represents the raw, unprocessed materials just scattered around the construction site. It's the isolated facts, the random text, the timestamps like 2026-02-27 or order ID 8721. On its own, it really doesn't tell us a story. Information, on the other hand, is the constructed, finished product. It's processed data that has actual meaning and answers a specific business question. When we take those raw facts and process them to say something like, hey, orders delivered this week increased by 12%, boom, we've just created actionable, valuable information. So, the real question is, how do we actually transition from a messy pile of raw data to that slick, actionable information? Well, we need a manager, and that's our DBMS, the Database Management System. It handles all the heavy lifting, securely storing data and strictly enforcing the rules. Now, in this module, we're specifically dealing with an RDBMS, a relational database management system. That R is super important. It means we aren't just dumping data into some massive, chaotic spreadsheet. We're storing it in distinct, highly organized tables that actually talk to each other. This relational aspect is an absolute game changer for modern apps because it prevents massive data duplication and keeps everything perfectly consistent. And our primary tool for this whole journey will be using MySQL. Moving right along to Section 2, the 3 schema architecture, safely organizing our data blueprint. To see how this RDBMS software keeps everything from falling apart, we have to look at the 3 schema architecture. This is a massive concept in database design, and it's broken down into 3 distinct layers. Layer 1 is the external schema. This is basically what the end users actually see and interact with on their screens. Layer 2 is the conceptual schema. These are the logical rules, the entities, and the relationships that map out the entire reality of the business. And finally, Layer 3 is the internal schema, which is all the nitty-gritty physical storage details of how bytes are actually written to a hard drive. This separation is brilliant because it gives us what we call data independence. Imagine a house, right? Data independence means you can completely swap out the internal plumbing or wiring, the internal schema, without having to tear down the walls or change how you experience sitting in the living room, the external schema. It's what makes our systems incredibly resilient. Next up is Section 3, Database Modeling Vocabulary, learning the language of design. Before we even think about opening up our drafting tools like MySQL Workbench, we really need to master this core vocabulary. Take a look at these interlocking pieces. First up, we have an entity. Think of this as the noun, a specific thing of interest that we want to track, like a customer or maybe an order. Next is an attribute, which is just a property or detail of that entity, like the customer's email address. Then we have relationships, which act like the verbs associating our entities together, such as a customer places an order. We've also got keys and constraints in there. A key uniquely identifies an instance, and a constraint is a strict rule that the data absolutely must obey. But hey, consider those last two a little sneak preview for next week. All right, Section 4, Reading Crow's Foot Notation, Visualizing our database rules. So once we've got our vocabulary down, we have to visualize our database rules using something called crow's foot notation. And we do this way before writing any SQL code. When you draw a line between two entities, the ends of that line actually tell a story based on two vital rules. First is cardinality, which simply answers the question, how many? Are we talking about a one-to-one relationship, one-to-many, or maybe many-to-many? The second rule is optionality, which answers, must it exist? Does a record absolutely have to participate, meaning it's mandatory, or is it optional? For example, must every single employee be assigned to a department, or can they be floating around unassigned? That's optionality in a nutshell. And this perfectly brings everything together into a really intuitive real-world example. Notice the line connecting our two entities here. On the left side, attached to biological mother, we have a single straight line, which signifies 1. Now look on the right side, attached to children, we see this branching three-pronged symbol. That right there is the actual crow's foot, and it signifies many. It's a universally understood visual map of a one-to-many relationship. Mastering these specific visual cues, that is your primary goal right now. Finally, let's hit Section 5, your Week 01 deliverables. Getting started on Assessment 1. Okay, let's bring all this soaring theory right down to earth for a second and talk about your project. Here is your exact checklist for the Consolidate phase. To successfully launch your design portfolio, you need to produce a one-page project domain brief that outlines your scope and your assumptions. From that brief, you'll extract and identify 5 to 10 candidate entities. You'll also need an updated glossary starter defining what those entities are. And lastly, pop open MySQL Workbench, get familiar with the canvas, and save your initial model file. These are the foundational stones for Assessment 1, folks. Knocking them out right now is going to put you in a fantastic position.